Okay, let's dive into this explainer and discover the application-first method for mastering Cambridge physics. Think of this as the game designer approach to your exam strategy. We're going to level up your answers so that every single paragraph you write unlocks new insights, and more importantly, unlocks those top marks. Whether you're studying syllabus codes 0625, 0651, 0652, 5054, or even looking ahead to A-Level 9702, this is absolutely crucial. I want you to picture a real Cambridge physics past paper question on magnetic fields. Most students tackle this in one of two disastrous ways. First, we have students like Alex. Alex looks at the question and completely overloads the answer box with raw physics facts. Just a massive brain dump of everything they know about magnets, with absolutely zero analytical depth. Then we have students like Sam. Sam is racing the clock, rushing through the paper, and completely misses the specific requirements of the command words. When we look at their flawed answers side by side, it is just a sea of red pen marks from the examiner. Alex gets 0 marks for application, and Sam drops easy points for describing instead of explaining. Today, we are going to fix that. We're looking at magnetic fields not as a dusty textbook chapter, but as a dynamic system. Now, what's really interesting about this slide is it challenges you with a lesson hook, making the concept feel absolutely necessary for real life, rather than just some decorative hurdle you have to jump over for an exam. Too often, we start by memorizing definitions, just like Alex did. But ask yourself right now, what physical effect actually depends on understanding this? Starting with this simple question forces us to see the necessity of magnetic fields. Why do we care about field lines? Well, because without them, we can't predict how a motor will spin or how a generator will produce electricity. When we realize that actual real-world measurements and predictions rely on this physics, the formal language we have to learn suddenly has a clear purpose. This application-first approach is incredibly powerful. It makes you far less dependent on memorized wording, which is going to save you when exam stress hits. Instead, it makes you highly capable of reasoning your way through completely unfamiliar exam scenarios. To guide us out of the trap of rote memorization, here is our roadmap for the explainer. We will cover the walkthrough framework, cause and effect physics, real-life applications, and finally, the exam lens. Let's move to Section 1, the walkthrough framework, and see how this builds our foundation. So the crucial point here is following these 4 linked steps, because the absolute best answers, the ones that examiners love to see, show both understanding and application. But to really crush this, we need to break down the physics-specific assessment objectives and reveal what top students use the PO framework. That stands for point, evidence, explanation, and link. Step 1 here is your point. Identify what you're even looking at. Step 2 is your evidence. State the relationship or formula. Step 3 is your explanation, the underlying physics making it happen. And step 4 is your link, connecting it to an observation or device. Now, I want to play a quick game. Imagine 2 answers. One just lists the formula for a transformer. The other says, an alternating current in the primary coil creates a changing magnetic field, which induces a voltage in the secondary coil. Which one follows Peel? It's the second one, right? Because it actually explains the steps. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, if you skip any of these 4 steps in your answers, your understanding remains fractured, and examiners spot it instantly. You need this complete sequence to truly grasp the science and secure those marks. Next up, Section 2. We shift our focus to cause and effect physics, which is how we communicate the science behind the scenes. This brilliantly illustrates how you should start with a concrete, everyday example, and only transition to symbolic physics relationships when you truly grasp the concept. This is where we see the real transformation. We are taking those red pen marks on Alex and Sam's papers and turning them into green check marks. If you start your revision purely with symbols on a whiteboard, you completely lose the narrative. The key is to move gradually. Begin with everyday language, like saying the magnets push away from each other, to ground the concept in reality. Then, apply our physics success blueprint. This is where you upgrade that everyday thought to formal vocabulary, changing it to, like magnetic poles exert a repulsive force. You always return to a worked explanation to tie it all together. It's like learning a new language by pointing at objects first before learning the grammar. We're rewriting those flawed answers live in our heads, and this is exactly why changing your phrasing adds marks. You're showing the examiner you understand both the what and the why. When dealing with graphs or fields, remember to focus strictly on cause and effect rather than just memorizing isolated facts. I want you to imagine a 60-second visual timer right now. You've got 1 minute to look at a magnetic field graph and write down what it means. Don't just calculate the slope because a formula tells you to. Ask yourself, what does that slope or direction actually represent in physical space? If the lines are closer together, the magnetic field is stronger. That is cause and effect. Whether you are dealing with fields, forces, particles, circuits, or waves, you must insist on identifying the cause and the resulting effect. Rote memorization of isolated facts simply won't survive the pressure of a tough, multi-part exam question. Sam lost points because Sam rushed and didn't state the effect of the magnetic field on the wire. We fix that by insisting on cause and effect every single time. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, Section 3. Let's look at real-life applications and why this micro-topic matters outside the classroom walls. Welcome to our interactive workshop. I want you to imagine a 60-second timer on the screen right now, and we're going to do a data scan challenge. Imagine I just handed you a massive, complex data table about maglev trains in the transport sector or MRI machines in medical technology. Your job is to extract the core trend. You should always be able to name at least one real situation from these fields and explain exactly why the physics helps us predict or improve outcomes. Ideas from magnetic fields pop up everywhere. If you truly understand magnetic fields, you should be able to pick an area on this list, let's say energy systems, and articulate exactly how electromagnetic induction makes our power grids possible. If you can't link the textbook theory to one of these real-life scenes within that 60-second window, you haven't quite mastered it yet. This is how you prove to the examiner that you're not just a robot reciting a textbook. Let's bring all this theory straight to the testing room with Section 4, the exam lens. Let's jump into challenge number 2, find the flaw. I'm going to give you a flawed sample physics paragraph, and I want you to mentally identify the exact sentence that is losing marks. Ready? Magnetic fields go from north to south. F equals BIL. The wire moves because of the field. Did you spot the flaw? It's the middle bit, dropping an equation without defining the relationship or the variables. When you sit down and look at a blank answer box, default to this exact 4-step structure on screen. Start with the definition to show you know what the core idea is. State the relationship or equation clearly. Write out the explanation using your cause and effect chain, and then anchor it with an application. This is the safest method to construct your exam answers, acting as a foolproof blueprint for structured questions. The examiner's commentary on that flawed paragraph would literally say, student failed to explain variables in equation limiting marks. This structure prevents that entirely. Now for Challenge 3's speed writing. You've got a 30-second timer to write one perfect Peel paragraph, but beware of these common exam weaknesses on the screen. Dropping an equation without explaining the variables is a surefire way to lose marks. These are the specific traps that students like Alex and Sam fall into over and over again. You write down the right formula, but don't explain the variables? 0 marks for understanding. You quote a process you memorized, like electromagnetic induction, but don't link it to a physical effect like a current is induced. The examiner has no clue if you actually understand what you just wrote. Or maybe you give an awesome real-life example, but fail to justify why it follows the physics. Avoid these pitfalls by strictly executing your speed writing through our blueprint. Now we arrive at the final system. Take a look at this revision cheat sheet. We are combining everything into 3 golden rules that guarantee top marks. Number 1, command word decoding. Know if you are describing or explaining. Number 2, PL framework application, which we've mastered today. And number 3, the time management matrix, knowing exactly how much time to spend based on the marks available. This table right here ties it all together. If you can answer these 4 prompts aloud, your knowledge is secure. Can you define the core idea and state the rule? Can you explain the physical change using cause and effect? Can you describe the quantity from an experiment? And finally, can you cite a practical use and justify the link? This is your ultimate diagnostic tool before you ever step foot in the exam hall. Imagine a progress bar on your screen right now, and it is hitting 100% mark potential. Ultimately, hitting these 4 benchmarks will ensure you are reasoning your way through unfamiliar questions instead of relying on memorized wording. This is the ultimate exam standard. It takes the application-first teaching, the cause and effect, the real-world connection, and distills it into an actionable strategy. When the examiner throws a completely novel scenario at you, you won't panic. You'll just apply the framework. Now listen closely. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. I'll leave you with this final challenge to test your newfound understanding. Can you apply the framework to something in the room with you right now? Look around. Is there a speaker playing audio, a motor and a fan, a charger plugged into the wall? Identify the device, trace the magnetic fields involved, and explain the physical cause and effect chain that makes it function. Mastering physics isn't just about surviving a paper, it's about decoding the world around you. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.